Okay, we're live. Welcome to the 10th ORTC Community Group meeting. I will be the slide deck operator, and I am your chair. So here's the IPR policy. Read it, take heed. We're now above 107 members if you include the chair. In this meeting, we hope to go over some of the recent changes to the spec, make some progress on outstanding items that are currently in limbo or have not been completely addressed yet, come up with a plan for feedback, and these links have all been published on the W3C blog. They've been sent out via email to the list, and they're also on ortc.org. So these are in the participatory link. Everything's been sent to the various places where they need to be, so there's no point in going over this again. This meeting is being recorded. It's also being broadcasted live, and we do have a scribe, so we can continue. Here are the appropriate links, the mailing list links, the contributor mailing list links, and there's a link here for you to join. You can also just go to ortc.org and shortcut all of that. And here's a link to the GitHub issues list. Okay, draft changes. I'll hand over to whomever is going to take the.
Yeah, I'll cover that, Eric.
Okay, thanks.
Okay, so a couple of things since the June draft. There are about 4 buckets of issues that we've been dealing with. The largest bucket is just RTC WebRTC 1.0 compatibility issues. So basically, we try to track new pull requests and new changes in the WebRTC 1.0 spec to maintain compatibility. And there were 10 of those issues. There were 9 issues related to codec capabilities and settings. In the June editor's draft, we didn't have very much there with respect to, for example, VP8 or H.264 or Opus. And so we added all those things in based on the various drafts, which are now final. Robin implemented the data channel, so he had a bunch of questions come up relating to that. So there were 5 issues relating to the data channel. And there were 6 issues in a miscellaneous bucket that we'll talk about. So generally, those are the changes from the June 22nd editor's draft that are now reflected in the November one. So more detail in the slides that follow. Okay, for WebRTC 1.0 compatibility, in issue 195, 1.0 has added a certificate management API, and there are a couple of reasons why that was needed. One of which is that for RSA certificates, they can take quite a while to generate, particularly on a mobile device. And in WebRTC 1.0, it's not as much of an issue because things like create offer, set local, etc., are all promises. But in ORTC, there's an issue because the DTLS transport constructor could potentially need to construct a certificate as part of the constructor. And if it's an RSA 248 on a mobile device, that could be an issue. So we did need to add support for that certificate management API, and I'll talk a little bit more about it. Basically, if you do use that certificate management API, then you need to pass the certificate to the DTLS transport constructor, so that you have, essentially, it's a promise to create the certificate, and then when that's created, you pass it to the constructor. In 219, WebRTC 1.0 has added a failed state to DTLS transport, so we added that as well to kind of just distinguish it from closed, which is all we had before. The name of what was previously called get nominated candidate pair, in 1.0 it's get selected candidate pair, which is probably more appropriate because it really does reflect the selected candidate, so we changed the name of that. There was an addition of something called RTC ICE credential type, which reflected the tokens that are under development in TRAM. So we added that. For some reason, I can't quite understand. We had misspelled ICE servers in ORTC, and it was camel case in 1.0, so we changed that. There was also an issue in the stats API where there was a dash in outbound RTP. That's been corrected in WebRTC 1.0 and now in ORTC. WebRTC 1.0 decided to add get contributing sources, which is something we discussed in ORTC but hadn't had it on the list of things to do. So we added that. And then the two other things which we'll discuss in more detail, which is RTC priority type, which is now an enum instead of a double, and degradation preference was used instead of frame rate bias. And we'll talk about that, and there's a PR that Peter has submitted to move that to RTC RTP parameters, and we'll get into more detail on that one, which I think is a good idea. Next. So people ask, like, why spend so much time on 1.0 compatibility? And the reason is that we're trying to provide the WebRTC 1.0 API as a shim on top of ORTC, and there's a pull request for that. And one thing you notice when you look at that pull request is that every little difference between 1.0 and ORTC reflects itself in some extra code that FIPO has to write for the shim. So it's both painful and potentially could create corner cases that can't exactly be mapped. So we try to be fairly meticulous about maintaining compatibility with 1.0 to not torture FIPO and the rest of us. Next. Okay. So here's the codec capabilities and settings bucket. So we didn't have a full list of the Opus capabilities and settings, and so we have now added those, and those include all the stuff that's in the Opus RFC, plus some of the options that are available in the 1.1 open source code. We've added a payload type attribute to RTX parameters. That's needed because we were missing essentially the associated payload type or apt parameter there, so we had to add that. There was an issue with things that aren't really codecs, such as FEC. There's a question of what it means, what the clock rate means, and it isn't appropriate to have a clock rate because some of those things can be used with any clock rate. So we just put in a clarification to say, basically, if you don't have a clock rate, it can be used with any clock rate. We also didn't have a full set of VP8 and H.264 capabilities and settings, so we added that in there. We didn't have RTX timer for RTX, so we added that in, and then for RID, we added the parameters of that. And then we had dashes in things like the H.264 parameters like maxfs, and since we've been trying to eliminate dashes, I believe, throughout the whole, both WebRTC 1.0 and ORTC, we changed those to camel case. As I mentioned, we added a section on Opus codec options in addition to the capabilities and settings. And then we had some clarifications on the exact meaning of what the capabilities were. Basically, for capabilities, if you don't include something, it means that it can't be set. And if you do have a capability, it's basically either the set of things that are supported for settings, or in the case where it's just one thing, it's kind of the default that you'll get if you don't set anything. So that's the bucket of capabilities and settings. And next is data channel issues. I don't know, Robin, do you want to talk about these?
Sure. One of the issues is that there actually is a port number associated with the SCTP transport. So we needed to add that to fully support. It's an optional parameter. Most people don't need to worry about it. The max packet lifetime max retransmissions, they just were need to be defaulted to the correct type to support the type that we support, the value range that we have. Some of the issue around the data channel negotiation wasn't clear in the spec, so we cleared all that up to make sure it was appropriate. And I forget what the deal with the send was, but it's just more behavior issues on how do we do things when we're sending data. And then there's a whole bunch of exceptions and errors issues that can propagate, and we wanted, based upon implementation that we found, so we clarified the issues around that. So next slide.
Okay. Actually, there was okay. So wasn't there a bunch of miscellaneous issues also?
Yeah, I added this between. Okay. I added one between.
Okay, so why don't you talk about the next one then?
Sorry, I didn't mean to throw you off there. So the RTP listener, the issue is that the programmer could create an RTP listener object, and be expecting to receive an unhandled event for incoming streams. But they've never created an RTP receiver yet because they're waiting for incoming packets before they actually create the object. So the question is, well, how do you know what the MID or RID value is, I mean the MUX ID value is going to be on the unhandled event if you've never set up a receiver yet, because we don't have anything on the RTP receiver or the DTLS transport or any other object where you can specify all the RTP header extensions before you actually create a receiver. So if you want to go to the next slide. So what we did was we added an optional sequence to the listener to say, hey, these are the head extensions you can expect, so that you can interpret the RTP packets header extensions as they arrive appropriately to be able to fire that event. And it's optional if you don't, if you've created one already, or you don't care about that.
Okay, yeah. So this is for the case where you never called receiver.receive.
Yeah.
So you never provided any header extensions, and so it has no idea what the header extensions are.
Correct.
So where is this an important case to handle?
Yeah, that was my question.
The programmer wants to only create receivers on demand, and as opposed to setting up pre-creating a receiver beforehand.
But when you send an offer, shouldn't you always be prepared to receive something?
You can, but it depends on how you program it. Like that's a case where you might want to just create receivers on demand as opposed to like pre-creating them.
But I'm just thinking, like, if I offered something, I should probably have called receiver.receive to at least be prepared to handle the stuff that I offered.
If that's your model.
I don't think we should be supporting every single possible model. I think this is going to lead us into just a real mess of lots of corner cases. I think that you can have stuff on demand where you have a receiver just sitting out there, and when one comes in, you fill it, and then you can create another one. You don't need to have callbacks for all these sorts of things if you already have a way of dealing with it, or already have a way for handling this case.
But the problem is that the actual event that comes in, you cannot. That would restrict the event from being able to be fired before you create a receiver. So you could create an RTP listener object, but you can't fire the event because you're missing values.
Right, but you can create a receiver just in case, and then when stuff comes in, it goes into that receiver, and then as soon as that's filled, then you can start creating another receiver.
Yeah, but then you created an object which you can't use until you create another object.
Yeah, but if you never created any receiver, then there's no payload types or anything specified, right? So stuff's coming in, and you're not prepared to handle anything that you offered. You don't even know whether it's audio or video.
Yeah.
Yeah, I mean, how would you, you get this event, how do you even know, what codec it is?
This isn't the model we've chosen elsewhere, is that, we haven't elsewhere decided to have, hey, here's this unknown thing, let's figure out what to do about it. It's no, you have an object that's plugged in, and that's set up to receive the stuff that comes in, and if you need to have another one, once that thing becomes used, you can then go and add another object, and that can get the next stream, etc. We've tried to avoid this type of programming pattern.
Yeah, I'm just trying to even think, you have to even have gotten a packet at all, you have to have a DTLS transport and an ICE transport.
Yes.
And so, and you have to know, generally, whether you want audio or video or both. So,
yeah, the issue is not whether it's going to be audio or video, because you can actually use the MUX ID to distinguish different streams that are coming in. The issue, as I said, is that you have to create a dependency object. In order to be able to use the RTP listener, you have to create another dependency object to make the RTP listener functional. So you have to create two objects.
Well, you need to basically be able. You need to have RTP parameters so you know what the header extensions are, so you can interpret the stuff that's coming in.
Yeah,
to even fire the unhandled event.
Right. So creating an RTP listener on its own without creating an RTP receiver under that scenario would be useless. There'd be no point in doing it.
Should you even should that even be possible?
You can't prevent it because you can construct an RTP listener based upon a DTLS transport the way it's set.
But if there's no receivers, does that even really make any sense?
Well, the other option is to throw an exception case where
yeah, that's what I'm thinking. Throw an exception if you have no receiver.
If you have no receiver, you'd throw an exception. That would force the programmer to pre-create a receiver before the RTP listener object could be constructed. Or the alternative is don't throw an exception and only let it function once you do create your first receiver. But then you create that dependency. So, I mean, you got to pick your poison.
Yeah, I mean, having no receivers seems like a very weird case, like none at all.
I don't know if it is, honestly, because the receiver is specific to the MUX ID, and you don't necessarily want to just plumb an empty receiver. So I don't know.
Well, but it's even okay if it doesn't have a MUX ID or not, just so long as it has a header extension so that you would know what the MUX ID, where it would be.
And you do want to, optimize as quick as possible to receive information. And sometimes your signaling path and your other path might be unrelated. And if you know information about the remote party before the signaling path arrives, you can interpret things faster than you could if you didn't. So, I mean, I don't know. Like I said, you got to pick your poison on this one.
Yeah, I think even in, yeah. Go ahead, Justin.
I just think we need to spell out the case better, like where we think we need this, and see if there's another way that, without inventing new APIs, we can make that work.
Well, yeah, I mean, even Emil, I think, would at least have one receiver, right? Like his issue is creating more receivers, but not like he always had at least one.
Again, depends on your scenario. And we ought to make this object function, and the rules got to be clear, because right now there is an ambiguity.
Yeah.
I'm not convinced we have to make this case work.
That might be, but then we should clarify to say it's not going to work, and what's going to happen if you do expect it.
Yeah. Yeah, I would lean towards kind of basically saying throw an exception if there's not at least one receiver. I mean, and that would clear it up, and I think most of the time you'd need at least one, so then you wouldn't. If you had at least one, right, then this would never come up.
I think we should punt this one to the list. There is a GitHub issue on this already, and it's in the specs. You can click the link and let's discuss it further there. And the scenarios as I described. So.
Okay.
Did you capture that in the minutes, Shijin?
Yes, I think so.
Okay, great. Thanks.
Okay,
Before we
great.
move on, can I throw out one other thought?
Absolutely.
So the crux of the matter here is that we already have a listener, and the listener already exposes some info about the packet that wasn't received, the payload type in the SSRC, but the header extension information is not there. So one option is to expose some header extension info and leave it up to the JavaScript to sort out what it means.
It can't interpret the packet that's coming in until it has the header extension info. And it actually creates problems even internally.
I'm suggesting that the event that gets passed from the event object from on-handled RTP, which currently has a payload type in SSRC, could also have a list of header extension ID plus value. That's an option. I don't know if it's a good option.
Yeah, that's an option too.
Where it doesn't add really more API service, just a little more info about what's in the packet.
Yeah, it
I don't
depends.
know.
As I said, pick your poison in this case. That is certainly an option.
Okay, are we ready to move on?
Although the problem is with that one, Peter, is that the information that comes in sometimes is literally binary too. For example, contributing sources and other stuff like that. And it might be difficult to even event up. Like you can event up that the header ID exists, but the data that's in it might be difficult to interpret and put into a structure.
Okay. So there were some miscellaneous issues. We had a bunch of fixes to the sample code, which was 237, 239, 241, and 248. 265, which Robin just talked about, which is the RID support for the unhandle event. We updated a bunch of the references, which are now published as RTs in 268. FIPO just filed a bug, I think against both ORTC and WebRTC 1.0, relating to what happens if you try to construct a sender or use settrack when the track.ready state is ended, and basically that should you should throw an exception for that. And then there was clarification of the behavior of create associated gatherer in 223. Okay, next slide. So for today, we thought we would focus on a bunch of video-related issues. So talking about the capabilities and settings in VP8 and H.264, the changes to 1.0 with respect to RTC priority type and degradation preference, and then talk a little bit about some of the issues that 1.0 has been talking about with simulcast and RIDs, and how some of those things would reflect themselves in ORTC and whether there's some ORTC changes needed or not. So next slide. Okay, so hope you can see this, but basically we took the VP8 capabilities out of the VP8 RTP payload draft, which is basically pretty simple. It's just maxFR and maxFS. And so those are defined as maximum capabilities of the decoder. And so there are only things you'll see when you call get capabilities on a receiver, not on a sender. And then in the case of H.264, there are the parameters that are in the video draft. And basically, profile level ID is a capability of the receiver. The packetization mode is a capability of both the sender and the receiver. And then we have a bunch of parameters which are things as defined, they're above and beyond what the profile ID says. So if the decoder has capabilities that it can do beyond what would indicate in the profile ID, then those are things that are indicated there, and those are also properties of the receiver only, capabilities of the receiver only. Just one thing to note is that unlike VP8, H.264 does not have a maxFR SDP parameter, and we'll talk about this a little bit more. It just has maxFS, but not maxFR. So let's talk about the settings. Next slide. So basically, what we said here is you're advertising mostly decoder properties in your capabilities. And then, like in offer answer, what you do is you advertise these things back and forth. And presumably, when the receiver gets the capabilities of the decoder, it sets them as kind of restrictions on the sender. So what we've done here is for VP8, we have maxFR and maxFS again with the same definition, but now for settings, they become settings of the sender, and as in contrast, they were capabilities of the receiver. Does that make sense, Peter and Justin? I think it does.
So basically, these would be clamps that if a track came in that was bigger than this, we would then squash it down to fit this?
Well, so the way I think about it is if, say you're an answerer and you got an offer with a maxFR and maxFS, right? That's saying this is the maximum my decoder can do. The presumption here is the sender will then conform to what that decoder said its limitations were. I mean, I guess that was my interpretation of what the meaning of that offer answer exchange was. Does that make sense?
Sure, sure.
Okay.
But I guess my concern is that this seems like the codec-specific property seems like the wrong place to have this, because they're not really anything to do with the packetization or the bit stream. They're really clamps on the resolution of the track, and it seemed like they really should be up a level.
Well, I think the codec things correspond to roughly the SDP FMTP parameters. Now there's also the encoding parameters, which are different, which are down a level, and we'll be talking about that as well. But these settings are roughly equivalent to the codec FMTP. Does that make sense?
That makes sense, but I guess like from an API perspective, it doesn't seem like our API should be driven by the exact SDP parameters for this type of stuff.
Well, the problem is if you don't have corresponding things, then you can't build a shim, right?
Well, sure. I mean, I agree with that, but I'm saying that like the shim may not be like a exact mapping in every case. You may call let me take the case of max frame rate.
Mm-hmm.
We could say that we want to put some max frame rate sort of parameter on the encoder, sorry, RTP sender encoder parameters thing, and then when you see that setting inside of the FMTP parameters, rather than calling some H.264 specific method, you call the generic method that says never send more than this frame rate.
Right, so we'll get into that in a minute. That's basically what's in Peter's draft on RIDs.
Yeah, we actually put some slides together on this specific issue because
Yeah.
we kind of agree with you, Justin, on this. So
yeah, so that's that's exactly what we want to talk about is the combination. Like as you said, part of the issue is that H.264 doesn't have a MaxFR; it only has MaxFS. So if you were only using codec stuff, like how would you control the maximum frame rate, right? In H.264, you can't.
yeah, or if you had a codec that doesn't even have anything, like a motion JPEG or something, well, what do you do then, right? So it kind of becomes a hodgepodge of stuff. There are codec-specific things like H.264 profile level ID, but there's others that kind of like probably more generalized. So
Right, or let me give you a more specific example. Like, what do you do if you're trying to do a shim and you have to deal with image adder?
Yeah.
So, like, let me taking this back a little bit. Basically, promoting these very codec-specific behaviors, I think, makes for a lot of API points, and doesn't always give you a general way to deal with these problems.
Right.
No, I was just looking back at the Opus PR, where like a ton of Opus parameters were added, and it's not clear to me that that's the ideal way of handling that sort of thing. That's sort of out of scope of what we're talking about right this second, but I don't think we should continue down that path.
Yeah, the problem is if you're, and I kind of agree with you, Justin, like we didn't in particular implement all that stuff, but you know, if you're trying to do a shim where the SDP is supporting it and you don't have it, then you're kind of messed up. But at the same time, it's not a great way to do things. It just creates enormous numbers of parameters. So you're kind of, but anyway, this is the exact question that we're trying to get into here. Is particularly with respect to encoding parameters and the RID draft. What do we do?
So I'm going to read a comment from Joe because he's having mic issues on his behalf. So it's tiny font. One issue we deal with today with Skype development is handling the frame sizing as it conflicts with UI element issues such as placement resizing based upon scale, etc.
Yeah.
Can you explain what that means? I don't really.
Well, I think we're going to get into it in a minute, but basically, all we have in ORTC today with encoding parameters is things like resolution scale and frame rate scale. And there's a scenario we'll talk about for example for screen sharing, whereas an example your mobile device might not be an exact multiple of your larger device like your PC or your Chromebook or whatever, and you might not want to use frame rate scale to scale down the frame rate in Simulcast the way you might in SVC. So I think he's getting at the exact point you made, Justin, relating to things like image adder or max height and max width and stuff like that with respect to the screen sizes.
So
and how all of this works.
I'm just going to read the comment on Joe's behalf. So enabling frame sizing, scale, etc. at the highest level of the API for easy config of the developer is a vote for us. So basically, he's plus one-ing you, Justin.
Yeah.
Okay.
Yeah, I mean we have some of the same issues. So we will get into this in a lot of detail in a minute or two. Try to figure it out. So I just wanted to talk about the 1.0 changes with respect to RTC priority type and degradation preference. So in the June editor's draft, we had something called frame rate bias, which was a double, which indicated the bias towards frame rate versus resolution. And we had priority of a double, which is, and so WebRTC 1.0 has gone to enums for these two things. Next slide. So we have the priority type enum, which I think corresponds to what's in 1.0 here, very low, low, medium, and high. And basically these correspond to, I believe, DSCP markings that are described in the transport draft. And then in degradation preference, we have maintain frame rate, maintain resolution, and balanced. So we basically substituted these things in 1.0 for what we had in priority and frame rate bias. So far, so good. Next slide. The tricky part, and this has been discussed in 1.0 in TPAC, and we've been talking about it here, is whether it makes sense to have degradation preference at the encoding parameter level or not. And as an example, within SVC, you could have something like the question is whether it makes any sense to say where congestion is experienced, reduce resolution in an extension layer, but not in a base layer. So certainly in temporal scalability, you really can't do that because the temporal layers have the same resolution, and you can't really. If you want to change the frame rate, you just drop an extension layer. So I think it makes no sense in SVC. And also, if you have both frame rate scale and this different degradation preferences on each layer, then I don't see how you can maintain the frame rate scale if you're saying you want to degrade differently in each layer. So then the question would be how you deal with that contradiction. Anyway, Peter has submitted a PR 397 to move degradation preference up to the sender, make it a sender property instead. And I think that makes sense for ORTC as well because it's kind of the same set of issues. So hopefully that PR will get accepted, get merged. I believe there's consensus to merge it.
Folks, just interrupt a little bit. I seems something wrong with my RRC. Can someone take over and then take script? I typed something I didn't get into the page here.
Okay.
So
okay, we need to do scribe by the sounds of things. Thanks, Shijin. Can somebody else jump on the IRC and help scribe, please?
I think I typed in for slide 18. From there, it didn't show up somehow.
I can't do it because I'll be busy with the slides.
Yep. Is there anybody that's listening either on broadcast or on the call here now that can scribe for us? We can't continue unless we have a scribe. So I need somebody to please step up. I'm operating the slides and have my hands full. So can somebody help out?
One thing is I can refresh and rejoin.
Yeah, why don't you try that?
Try that, Shijin. Thanks. Here, I'll put the IRC info in the Hangouts chat here. And if it happens again, maybe somebody else can help out.
Are you able to rejoin? Or someone else able to join? We just need someone to join and scribe.
Yeah, saw Shijin rejoin.
Yeah, okay, all right. I'm gonna just take whatever from my memory from, I think, slide 18 and make it brief. All right, go ahead, Bernard. Don't wait for me.
Okay.
Okay.
So next slide. So this is basically what the encoding parameters and RTP parameters would look like with those changes. So basically, degradation preference is now in RTP parameters, and I guess the proposal is just to stick it at the end there. And then basically we end up with RTC priority, type priority in encoding parameters, and the degradation moves is removed from there. Peter, is this more or less what you had in mind with 1.0?
Yeah, that's exactly what my pull request has, right?
Yeah, I hope so. That's the intent.
I agree with this, but just to throw a little question in here, does anybody see a need to do this like in a simulcast scenario where you would want to have some simulcast streams having different properties than others?
Well, I think you want different properties, but we'll talk more about how you would do that. It's more along the lines of what Justin suggested with things like the max height and max width and the max frame rate, I think. I don't think degradation preference is probably the right way to do that.
I can't think of a scenario either. I just wanted to throw it out there as a question.
I think keeping it simple like this is probably a good way to start.
Yeah.
Okay, then we can continue. Unless someone has an objection.
RIDs.
Okay. So the next bunch of questions related to how ORTC should support RIDs. And we just thought we'd pause for a little commercial for RIDs.
We love RIDs. They're great. Thanks, Peter.
Okay. Go ahead, Robin.
So we already have a MID, or what we're calling a MUX ID in the actual property, that identifies the pairing between a sender and receiver. So you can basically tag the packets as they're going out, and when they arrive, you can demux them and send them to the appropriate receiver on the opposite side. And you can create these, nice mapping. The problem becomes, especially with simulcast streams, because you can have multiple streams in the receiver, is how do you identify one stream versus the other? Because you got these SRCs coming in, and they're coming in to the same receiver because they have the same MID ID, but they're actually different simulcast streams. And there's ambiguity that can start to arrive when, especially when you have RTX or FEC coming in there, potentially with SVC. When you have SVC layers on top of, and they're on different SSRCs, which can happen with some codecs, although I don't know if we necessarily want to support that or not, there can be ambiguity there. And during changes between SSRCs, like if you're changing from one SSC to the other because you're receiving, for example, from some kind of SFU box and it's changing the sender at that time, well, then you can have some ambiguity when packets arrive where it goes. So the MID really helps to clarify the simulcast stream and really tag it and say clearly this SSRC belongs into this bucket without a lot of guesswork. And it really simplifies the programming of all this, I can say from personal experience. So I really love it.
So I didn't understand the SBC bullet 3.
Well, I guess if you have multiple simulcast streams each doing SVC, you might get confused, like which layer corresponds to which simulcast stream. Is that what you're saying?
This would be SSRC is a different, because if you
so that would be for like MRST or something.
Right.
Okay.
But even in MRST, we still know, we still can tell which is which just by like the actual headers that exist within that bit stream. Like I think that this allows for us to correlate the RTX infect things for a given primary flow. I don't think there's anything for I don't think RD does anything to correlate different primary flows.
I just find it easier. I mean, just from speaking from programming this, to be honest, I don't like having to, at the receiver level, start having to look at the bit stream of the different layers. It's just nice being able to see an SSRC coming in, look at its tag, go, oh, I know where to go, as opposed to examining the details of the packet. So just
in different simulcast streams will have different RIDs, and so different SSC layers will have to have different RIDs too. So I don't understand what you're saying.
Well, wait a second, Justin, so just make sure I understand this. So say I have two simulcast streams, each with temporal, right? Are you saying that layer 0 would have a different RID than layer 1, even though they're part of the same simulcast stream? Or would they have the same RID because they're all part of, say, simulcast stream 0 or something?
Oh, if you're splitting your temporal streams into different SSRCs, then would they have the same RID or not?
Right. But they're all part of the same simulcast stream, even though they're different SSRCs?
Those would have to have different RIDs.
Yeah.
They'd have to have different RIDs, not the same RID? Oh.
Everything that's not a redundancy RTP stream has to have a separate RID.
So you're splitting the layers with different.
Yeah, because it kind of maps to the SSRC, so I guess you're right.
Definition of a RID is the RTP stream that's not a redundancy RTP stream, aka a source RTP
but
stream.
if it wasn't MRST, then it would have the same RID, right? It's just the MRST thing that creates the need for different RIDs.
Yeah, but Peter, my understanding of RIDs, the way that they're defined is that they are basically identifying the repair flows for primary streams, not grouping different, simulcast or SVC streams, because there are other mechanisms that exist for that.
Okay,
Anyway.
so I think we should probably have some additional issues, Robin, particularly with respect to routing. Yeah.
There's definitely an interpretation difference of what its intention was. So it's good that we discuss this so we can clarify it.
Okay.
What?
The read restriction identifier?
No, that's actually, I changed it on the slides, but it doesn't show up here. But it's not a restriction identifier. It's an RTP stream identifier, specifically a source RTP stream identifier. If you go look in the taxonomy draft, which just became an RFC, the thing that says source RTP stream, that's the thing we're identifying. However, they didn't define the phrase source RTP stream for dependent streams, only for encoded streams. So in the SVC case, the taxonomy draft has a flaw.
Okay.
Anyway, it's the RTP stream that's not a redundancy.
Okay.
This has implications as well on the unhandled event. Basically, you already had the MID identifier that comes in from the packet. It's great to have the RID as well, and there's no reason why we can't fire it as additional information. So I just propose that we add it there. And then the question becomes, and I've got 2 slides here, what do we do about these encoding IDs, and how does an encoding ID related to RIDs? So now we just discussed whether RIDs just a moment ago were specific to a particular layer or not. So there's 2 models you can do then, is you could say that the encoding ID basically defines all SSRCs within that encoding or within that layer. So it's a direct one-for-one mapping where an encoding ID becomes a RID, or if you were doing it the way I may perhaps misunderstood, that the encoding ID on the base layer becomes the RID for all layers, if we're talking about the MRST case. So
if we ignore temporal scalability for a second, the encoding ID is the RID is the encoding ID.
Okay.
And so an encoding will only ever have one source RTP stream.
Right. So go to the next slide, just here. I just wanted to say, do we really need a separate RID? And I was like, please don't. Let's just keep the encoding ID and define it to be the RID.
Right. The encoding ID should go in the RID. Just like we have MUX, we call the one thing MUX ID, and then it goes in the mid header extension. This is
right.
The encoding RID.
So for the case of temporal scalability, Peter, is that still true, or were you saying that dependency encoding ID would also be encoded as a RID?
So if you did temporal scalability on a separate SSRC, you would have to have a separate.
Right. So encoding ID isn't always the RID, I guess. It could be the dependency encoding ID in the case of MRST. Just trying to figure that out. It would be the encoding ID in the case of MRST, right? Yeah.
So your source RTP stream and your FEC RTP stream and your RTX RTP stream will all stick the encoding ID in the RID for all of them. If you also have separate RTP streams with separate SSRCs for temporal scalability, the question is then what goes on that RID, or what value goes there, and it cannot be the same RID as what's in the encoding ID, because then you would have more than one source RTP stream with the same RID, which doesn't make sense.
Yeah, I think that's an invariant we need to maintain, that each source RTP stream has independent RID.
Okay, then that clarifies it, and we can fix the spec.
So either you would have to have a separate encoding for a temporal scalability that has different SSRC, or you would have to have on the encoding parameter something that said my temporal scalability RID is X.
You know, my sense is that sending temporal scalability as independent SSRCs is probably something we don't want to support, like in the spec.
Yeah, that would probably be okay, because at least the way we do it, it's a separate codec anyway, so it wouldn't be involved in this, and I don't think it's going to come up really in any of the standard ones.
I mean, I think generally we want to push people using SVC toward like SRST, And like, in worst case, simulcast, which is basically, the MRST case. But certainly for things that really form one contiguous stream, like temporal scalability, we can just mandate that it be, basically single SSRC. And if we really make a use case for it, we can revisit it later.
Yeah, I think all new codecs, certainly VP8, VP9, all the future stuff will all be SRST. So that's probably okay.
I'm completely fine with that. I really like that. I prefer that.
Yeah, certainly less confusing. Okay, we should probably take some good notes on this because it may have changes elsewhere. Okay, so now more to the point that Justin was bringing up. So here's a simulcast scenario, and we wanted to figure out how ORTC will handle it. It's a case where you have a mobile device and a PC both trying to get a screen share. And the mobile device has a smaller screen size as well as lower maximum frame rate capability. But the mobile and the PC, they're not in an exact ratio of one another with respect to the screen size. And similarly, with respect to the frames per second capability, they may not have a defined ratio. And in any case, you may not want to use frame rate scale for that. It's more for SVC, temporal scalability. You may just want to make sure that the frame rate for the mobile is within its capabilities, and for the PC, same thing, without using frame rate scale. So next slide. Oops, I think there was another slide in there, Robin.
Oh, here it is. Sorry about that.
Okay.
Make
So
sure
the question,
I haven't skipped two here. Sorry. There you go.
Yeah. So the question is whether what we have in ORTC right now is enough, and whether we need to add more things. So currently all we have is the codec settings, which Justin was referring to, like MaxFR, and the problem is they're not the same for all the codecs. And then we have the resolution scale and the frame rate scale stuff. But there are a couple of problems with that. One is that MaxFR is only applicable to some codecs and not others, but also it's just a maximum frame rate for all the layers in the codec. So it doesn't really allow you to control what each individual max frame rate might be for each of the layers. And then in Peter's RID draft, there's a whole bunch of new stuff like max width, max height, and max FPS. And the question is whether those kind of things should go in the encoding parameters. The advantage of doing that is that that's not codec specific anymore. It applies to all the codecs and gives you some uniform way of dealing with that. And also, I think handles this scenario a little bit better than what we have in ORTC.
And I would add it stops eating payloads for breakfast every time we need to have a distinction between these different parameters, which is really nice because we only got a very limited subset of them.
I didn't follow what you said there.
So does that make sense to you, Peter and Justin, that this should go in encoding parameters?
Well, I'm really not a fan of the max width and max height.
Okay.
Max frame rate I can sort of see, and that's being debated back and forth with in the WebRTC.
Can I just ask why you're not a fan so that we are all on the same page?
Because the application already has control over exactly what width and height they're going into the encoder in the first place.
Yeah.
You mean just the resolutions, just the stuff in the constraints?
Yeah, it's in control of the track that's feeding the frames into the RTC. So why does it have to put this second place where it can control what width and height come on?
Yeah, I mean, basically, if you're happy with just resolution scale, moving it up and down, you probably don't need this. It would be the situation where the mobile wasn't, for example, an exact ratio of the PC or something like that, I guess.
Yeah, but you still have, I mean, I think my biggest concern here is that, like, what happens if we have both knobs for resolution scale and for max width and max height? How do those things interact?
Right. Well, that's the whole question, the same question for frame rate scale and max FPS, right?
Yeah,
and max FR. If you throw all that stuff in there, what the hell happens? I don't know.
So in 1.0, we didn't take frame rate scale. We instead, I think, decided to have a max FPS parameter.
Actually, we never got consensus on that.
Yeah, but I think there seemed to be like rough consensus building for max FPS. And
yeah. I mean, frame rate scale, I think, only makes sense for temporal scalability, not for simulcast. That's kind of my sense.
Right.
So maybe we should just say that it's not, doesn't apply to simulcast.
Right, and also for temporal scalability, like there's no way for us to create like the multiple encodings right now, right? I mean, like, do we create 3 different encodings with frame rate scale when trained with all the same SSRC for doing temporal scalability?
No, I mean, it just influences the, in fact, it is kind of weird, right? Because not all values are even possible.
Right. So, I mean, perhaps we need some other way of doing temporal scalability, and then max FPS being like a upper bound on what FPS we support. You know, we could have, I mean, I'm with Peter on, I generally feel like the track should control what is going to occur, and that you should really adjust your track, because then that avoids a lot of other problems, like, well, if you have like your graceful degradation kicking in, and you set like max width and max height, like how do those things, you know, work out so that you avoid having a case where you thought you were sending a simulcast of 320p and 640p, but instead, like, you know, the 640p is being degraded and you're sending 2 320p.
Right, exactly.
Yeah, and also just for a max width or max height, those can be controlled by the track as well. It is
sorry. So I was gonna. So that implies then that if we do this on the track where the track defines it, then you need 2 RTP senders in order, because they have individual tracks, in order to control it. So you can't kind of shove it in the same sender, which I'm completely fine with. But
well, no. You get the scale.
Yeah, you can get the scale. True. But you can't say like mobile on that's has a rotation on landscape mode versus portrait mode. You can't define, you know, like what they're going to see.
Changing aspect ratio is like a whole different topic. Yeah, right. I mean, like we don't know how to do cropping or any of that sort of stuff. I mean, we have no mechanisms for that.
Yeah, but it's a great question, Justin, about like the potential contradictions between the codec parameters and some of these things. I'm not enthusiastic about having to go through a whole constraint resolution algorithm for all of that stuff.
Yeah, the only change the picture aspect ratio, you know, once we define whatever the size of crowding outside of the RTC stack. That should all be done by the media capture part. And scaling really makes sense.
Right, but I mean, the case that would be like the pathological case would be like, I want to send my one simulcast layer as like a landscape and the other one being a portrait or some other.
Right, some other weird thing, yeah.
Like, we would need a whole new set of rules to, like, and like API surface to control all that. That would just be very messy. But just in general, like, I'm very concerned about having a lot of different knobs.
Right.
And having clear interactions defined between the knobs. So like if we decided we were going to have a max width and max height, I would sort of say we should do this, but it should be like, you know, a one of type of thing where you either set resolution scale or you set max width and max height, and basically they amount to the same thing underneath. You know, it just basically comes up with some ability, some non-cropping, non-padding way of scaling down the input thing.
Right.
And also resolution scale sufficient, given that we agree that if you express one in terms of the other, resolution scale is probably sufficient. So max FPS, you know, might replace frame rate scale. Like that might be where we actually end up. But I don't really feel like we should add additional things unless we have a very clear use case and we can say, oh, that's definitely not satisfied by like the APIs we currently have.
Yeah. Well, so let me ask a question. If frame rate scale isn't needed for simulcast, and it's kind of, and we have temporal scalability as geometric anyway, do we even need frame rate scale? Like, couldn't you just figure it out from the temporal layering? I mean, what else could it be, right?
Well, I think that I'm not exactly sure, and partially it's just because I kind of forget how you actually define temporal. You know, basically, what APIs do you call to set up temporal scalability? Like we know how you set up spatial scalability for, you know, various configurations, including SRST, but it's not clear to me how you set up temporal scalability.
Well, I mean, basically, and we've talked about this at various points. If you know how many, all you really need to know on the encoder is how many layers of temporal you have. Right? If you know that, then you basically need, that's everything you need to know. So that was always one of my questions, like, you know, frame rates, do we even need frame rate scale if you just know the maximum number of temporal layers you want to send?
So yeah, I think that would be my preference. Like we have, I just talking with Peter here, like, you know, we have an example in the spec where we basically create a temporal layer structure based on having multiple encoding parameters, each with a frame rate scale and a dependency sort of graph in there, but like, it doesn't really talk about combined spatial and frame rate scaling, or spatial and temporal scaling, which we, you know, conceivably would basically require a 9-entry, you know, RC encoding set, which seems like it may be somewhat absurd.
Yeah.
Yeah, you came up with a model before where you're basically saying whether it's on or off, or maybe an end to the number of temporal layers. And that seems like a
right, and like the codec can have some discretion on exactly how those are used. That seems like that might be fine.
Yeah, I think yeah.
Just going to read Joe's comment here. Bottom line, we want a max width height at the presentation layer. I think enabling the UI developer to set those constraints at the UI layer based upon whatever the feed may be best is best. Sorry, said something else.
Yeah, that we can already do.
Today, not only video apps, there are the same. Not all video apps are the same, especially when embedding in existing web apps with a ton of UI complexity.
Yeah. Yeah, so I think we need to look at whether we even need frame rate scale at all, even for temporal. Because we have, right, we have maximum temporal layers already in capabilities. Why is that not a setting?
I think we haven't really done a lot of this actual detail work, scalability. I think is really probably the underlying answer.
Yeah. But I guess you're going to implement this, right, Robin?
We're going to try.
Okay.
It's kind of hard to do without a definition. Therein lies the problem.
Yeah. Yeah. So at least your proposal, Justin, would be just do max FPS for now, and dump frame rate scale. And
well, I think these things should match 1.0.
Yeah. Right. So
yeah, they should match 1.0.
If 1.0 adds max frame rate, then we should add max frame rate. And if it adds nothing, then, well, maybe we could still add max frame rate.
But there's no proposal in 1.0 to add max width and max height, right? Despite what them being in the RID draft.
I mean, they've certainly been hinted at, but definitely the consensus is weak. There's no consensus there. So.
Okay.
Can you guys hear me?
Yeah.
Very faintly, but yeah. So if you speak up a little bit, we can hear you.
Let me try this. Sorry, I've gone through 3 different mics now. It's awesome. This is Joe. So I heard, I guess, someone say that the control of max width and height is already there on the UI layer. That's correct, right? In the current spec?
Well,
the spec layer, yes.
Okay, so what you're talking about here is constraining the width and the height through the transmission of the video?
Yeah, the encoder.
The sender.
My vote on that is to not include it. I don't think it's necessary. Frames per second, probably, but not width and height. Why again would you want to do that?
Well,
crosstalk. We're sending to a mobile device that doesn't even. You're sending 4K stream to a mobile device that doesn't even have that kind of resolution. What's the point? That's kind of the reason.
You could use resolution scale, but it's just if the mobile to the PC wasn't exactly a multiple of resolution scale, but it's an optimization. You could basically use resolution scale to just scale everything down.
Okay.
So, yeah, I mean, we're just trying to get some very basic things in here, just enough to make these basic scenarios work. So, refinement, we can wait till later.
Should we just I actually like the idea of just whatever comes out of WebRTC 1.0, we just match 1 for 1. And
yeah, I mean, I think right, Harold said I think the pull request for MaxFS would be okay, right? That's what I remember from the last editors meeting.
Well, no, I don't think there's consensus on anything.
Oh, not anything? Oh, okay.
Yet. If we push for max frame rate, maybe it could happen, but I don't think it's like it's a done deal.
Okay. Yeah. Okay, but we probably should try to figure out if we need frame rate scale anyway.
To be honest, I think we need to look through all of the RTP encoding params a little bit again and just make sure we have a good understanding of what each of those things is used for.
Yeah, that's a good idea.
I just to be max bit rate and min quality and all that sort of stuff.
Right.
I don't think I've ever really kind of fully understood or fully detailed exactly how those things are to be used.
I think we're all exactly the same at WebRTC 1.0, except for you can specify the payload type, and you can specify X and RTX.
Yeah, but some of the same things, yeah. No, I agree.
One of those, I think min quality is the only one that's...
Yeah, we couldn't figure out what that meant.
Right, that's quite true. I think that there is an open question around in 1.0 about how do we deal with degradation intersecting with simulcast to avoid the case that I was talking about where you get two 360p's because you're, on a bandwidth and a 720p.
Right.
I had to how that could be dealt with.
Yeah, I think it makes it easier having degradation at the RTP parameter level. But yeah, I agree that could happen.
Okay, are we ready to move on here? We were kind of...
Yeah, I think I agree with Justin. We need to go over this stuff more on the list, all of what's in encoding parameters, and see if we understand it.
So we managed to catch that in the... Let me just take a look at the RSC chat. Yep, we captured that in the...
Yeah, I'm all for snipping out some weeds, and basically we're done anywhere. So aside from asking questions at this point.
Yeah, cool. Okay, so that's about it, folks. Is there any? Does anybody have any questions or comments regarding the direction of the API at this time? If you're working on something that's ORTC related, we'd love to hear about it. Now's your opportunity to get a free plug.
I have a comment. So while Philip Henke was working on the SIM to implement peer connection on top of ORTC, he ran into some annoyances with how the ice gatherer works. So after talking through that with him and Justin, we came up with a proposal to fix it, and I sent it to the list just before this meeting. So the idea is basically to make ice gatherer more like DTLS transport, where you can create some parameters ahead of time and then pass them in the constructor, just like we do with the DTLS certificates. So I don't need to explain it all right now. I'm just letting you know that I posted it on the list. I think
I saw the note that you sent to the list, and thank you for that, Peter. And it looks like Philip Henke, aka Fippo, has already responded with a favorable response. So that's great.
So it's unsurprising, but
yeah. So this also relates to, I think, to a couple of bugs in both 1.0 and ORTC relating to gather policy of none. I think also.
Yeah, in theory, it sounds good, and I'm in favor. We'll have to go through the details to make sure we don't run into some weird corner cases, but it sounds like a good idea.
And the critical aspect is that the creation of the ice and credentials needs to happen separately from the actual starting of gathering. I think Peter's thing resolves that.
The other thing was I noticed that we went back and forth about the SCTP transport and the port number and so forth, and I thought we decided not to add a port number there, but then I noticed in the latest version there is a port number there, so I'm a little confused about that.
Can you specify what slide that was, Peter?
Oh, it wasn't a slide.
It was back in the data channel slide.
Oh, yeah, I guess there was a point on one of the slides that mentioned the port number.
Yeah, there is confusion on that because there was discussion about whether you need it or not, and it seemed like, my understanding was the conclusion was it was an optional parameter rather than something that.
I'm just curious why we even have it as an optional parameter. Like, I can't come up
because If I remember correctly, it's possible to specify it somewhere, and for compatibility reasons, I believe it need, but I can revisit that to make sure why. I honestly don't remember.
This is in the SDP, Jessup, isn't it? No.
I don't think you can change it to something, can you?
Yeah, you can change it to whatever you want.
Yeah,
Right,
I think you can. Unfortunately.
And
It's actually on the wire.
Support it.
Well, it's actually it's on the wire. Like what the SCTP tunneling stuff. It actually sets a value there, and so if it's a different value than what the other side is expecting to get, they're gonna be unhappy.
Yeah. I remember being related to that.
Totally gross, but I feel like this is one where you just said bear hug it and deal with it. I don't.
Does that mean you can actually set up more than one?
No, you only set one because I guess theoretically, no, because there's a connect method, like a synact sort of thing, and you have to specify what port you're going to use.
I don't know. I'm saying is, can you put in the SDP2 SCTP lines different port numbers?
2A equals SCTP port. Sure, you could.
No. 2 M lines.
Yeah.
In theory, yes.
Different port numbers bundled on the same transport.
Yeah. We decided not to support that, but that's. If we hadn't put that restriction in, then yeah. It's stupid. We should just deal with it. Eventually, it'll get resolved.
Yeah, I don't particularly like it, but for compatibility reasons, because I believe it comes from the SDP, we needed it, and that's really what it came down to for the shim.
All right.
I'd be happy to toss it in the garbage if we can.
No, I'm persuaded. Let's move on with our lives.
Okay.
Just make sure to capture that, so we're okay to keep that, right?
I think that
Sadly,
was the.
with reluctance, yes, we keep it.
Okay.
I think that was the consensus on the call.
Yes.
No one's pushing back on it extremely hard, so it sounds like we're going to just roll with it. Although no one's really all that happy about it.
Okay.
Thanks to everybody for getting on the call with us and walking through some of this stuff. If there's any more comments, you're free to let them fly. We've got another 15 minutes remaining, but if we don't have anything else, I think we're going to shut her down early. There's a few slides here. Sorry, go on. Who is speaking?
Does anybody have more info on the Opus changes? I just want to sort of wonder if there's.
Sure, we can. Yeah, why don't we talk about those?
Okay.
In fact, Eric, probably the simplest way is just to bring up the November draft, and we can go to the Opus section and talk about that.
Okay, give me a moment here.
Yeah, just for a little bit of background, Justin. Like in Edge, we don't implement all those zillion options because, frankly, most of them you can do in band anyway.
I sent a link in the chat of the Google Hangout to the latest draft, and in there it includes all the additional stuff regarding Opus, what's possible. It comes out of the codec, as well as what's possible to set.
Yeah. Okay, so just go to the Opus capabilities and we can talk about them.
I'm going to give a better specific link.
There we go.
Right there you go. That's it.
Yeah, so this is basically all the stuff that was in the RFC in all its glorious detail.
Yeah, right.
And these are properties, sadly, that are in the SDP that you can plumb. So
now they're all optional, though, right? Yeah.
Yeah, but so the fact that we have things about whether you're going to produce stereo or something hidden on Opus seems wrong to me. Like that seems like that's something we should be getting from like the media stream, or like the output device or whatever, or from the media stream track that we're about to plug in.
Right.
I don't feel like that's really I don't even know how we'd wire this.
Well, and you also have num channels, right? So like, why would you need that other thing too?
Yes.
The other thing I think is a little awkward is that predict and a whole bunch of these things say what it prefers.
Yeah, right. It's an application thing, right? Like, how does a browser decide whether DTX should be used or not?
Well, it's saying the receiver is saying I'm capable of doing either, but I prefer one. Like, that's not capabilities anymore.
Right, exactly. That's my point. Like, the browser should have the same value for this for all applications, but these are clearly not the things that make sense for all applications. Like, what should max average bitrate be? What should the browser say about that?
Now for something like in-band FEC, if that really is optional for a browser to implement, then I guess that's a real capability. I don't know. Is that optional?
Yeah. Yeah, actually, that's a good point because, well, actually, they're all bool. Wait a second. I think this is screwed up, Robin, because these
there's a mistake on these. Don't ignore the types, but the types are supposed to come from the RFC. We had an error in there, so we'll fix that. But these all directly come from the RFC and what the definition says that is available in the STP.
But are they really capabilities? Is I think Justin's point.
They are in the sense that you do have one side that can send to the other. The question is, should the browser emit these as capabilities, or is these something that decided strictly by the application developer and the browser doesn't need to emit it?
I think if it says prefer, then it's not a capability.
I mean, I think I can